everyone, this video is going to be all about metric conversions and the use of table C on converting back and forth between large and small measurements. So the big idea here is that the metric system, unlike the system that we use here in the US with pounds and inches and feet, metric system uses factors of 10 to convert between small and large measurements. So instead of having to know that there are 12 inches in 1 foot, we're always going to be working with factors of 10, like 10, 100, 1,000, 10,000, or, dividing 1/10, 1/100th, 1/1,000,000th, something like that. All these conversion factors are going to be listed on your reference table, so although you'll become more familiar with the metric system throughout the year, it's always there on table C to help back you up. And we'll use that in a couple of example problems as we try and convert between one metric unit to another. So this first practice problem has to do with the radius of a carbon atom. What I want to know is how big is a carbon atom if its radius was measured in meters? Well, meters is a horrifically non-useful unit to use if you're looking at something the size of an atom. And in fact, if you look at table S, that's where you would find the radius of a carbon atom in the first place, right? All the way over on the far right-hand column, you'll see atomic radius listed, and it has this unit of pm. So we'll just write down the value that I see for carbon, which is 75 pm. And what I want to do is convert that measurement into meters, which we know is just the m part of this pm. And table C kind of holds the secret for how to deal with that conversion. It's right on the very front page of your reference table, and you'll see there's this symbol P that stands for pico that's going to help us make this conversion actually happen. So the way to read table C is that one of our altered unit, in this case we've stuck some prefix on to a base unit like meters, liters, grams. If you want a couple more examples of base units, you can just slide right on over to table D, right? Here's our meters, liters, joules, all that kind of stuff. Back on table C, though, one of those altered units is going to be equal to a certain amount of our base unit. So in this case, our base unit that we're dealing with is meters, if we just get rid of that prefix. So 10 to the minus 12th meters is equal to 1 picometer. That's a really tiny number. We'll deal with scientific notation a little bit later in the year, but you'll be able to use your calculator to see just how small of a number that is. So we're going to use this kind of exchange rate that for every 1 picometer, we have 10 to the minus 12 meters to solve for this meters to picometers conversion. There are two ways that you can go about doing this conversion. To me, it doesn't matter which way you do it. As you move up into chemistry or other advanced sciences and maths, you'll probably see one method preferred over the other. But in this case, pick whatever feels more comfortable for you. So I'll start with just a simple cross multiplication setup. I know that I have 75 picometers, and I've changed that. Well, no, I haven't. I don't know how many meters 75 picometers is, right? We aren't 100% sure. So we have this relationship that 75 picometers is some number of meters. What I do know from table C is that 1 picometer is the same thing as 10 to the minus 12th meters. So it's kind of like we're wondering, all right, if I know this, and I've changed it to this, and I know this, I should change it to some corresponding number. From here, you can just cross-multiply to figure out what your x might be. In this case, we do have to ignore units to make it make sense, which is what makes it unpreferred later on in science. But I see x is going to be equal to 75 times 10 to the minus 12th. And I know x was a measurement that was going to be made in meters. Okay, we'll deal with this a little bit later. I'll set up a second way. And this is what's going to be preferred if you go on to advanced level sciences. I know that I have 75 picometers, and I want to exchange each and every one of those picometers for meters. So if I want to exchange, I've got to trade one thing in for another. The reason I wrote this in this particular way was to show that I am going to trade in every picometer. Each will cancel, until I have only meters left. You can kind of think of this as the units canceling on the top and on the bottom. And what I'm left with is 75 times 10 to the minus 12 meters. You'll notice that this gets you to exactly the same spot. If we look at just how tiny that number is, and it should be really tiny, right? We know atoms are not huge amounts of meters. They're tiny, tiny fractions of meters. What this 10 to the minus 12 tells us to do is to move our decimal place over 12 spots to the left. What it's really telling us is divide by 10 12 times, which is going to have the end result of moving our decimal space over 12 times. So when I do that, that's the same, I should have 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 5 meters. That's incredibly small, isn't it? And when we talk about scientific notation, we'll find a more proper way to write this, but for now, this is where I want you to be able to get, knowing that we're getting an incredibly small number because we're using this incredibly small exchange rate. Let's take a look at another example. I want to know how many joules are equivalent to 5.6 kilojoules. This is something you might encounter in one of those heat calculation problems. And again, you're going to find that this K is something that we can find right here on table C. It's up at the very top. Keeping in mind that one of our altered unit, in this case we're dealing with kilojoules, is going to be equal to 10 to the third of our unaltered unit, just plain old joules. I'm going to use this exchange rate to help me convert between kilojoules and regular joules. So my conversion factor is that 10 to the third joules is equal to 1 kilojoule. So using my cross multiplication method, what I can say is that 5.6 kilojoules is equal to some unknown number of joules. What I do know is that 1 kilojoule is equal to 10 to the third joules. That relationship comes from table C. Cross multiplying lets me know that X is equal to 5.6 times 10 to the third joules. This is actually proper scientific notation because my leading number out in front is between 1 and 10. But again, that's either here nor there until later on in the year. Let's take a look at our second method because it should lead us to the same place. I know I've got 5.6 kilojoules, and I want to exchange every single kilojoule for 10 to the third joules. My units cancel out on the top and the bottom, and I'm left with 5.6 times 10 to the third joules. Now, if you are unconvinced that these things mean move the decimal point over, you can always type this into your calculator to see if you'd get the same result. Seeing as this number is positive instead of negative, we're going to move our decimal point over to the right to make the number larger. So what I predict that this should be is 5600 because I've moved my decimal spot 1, 2, 3 times to the right. And let's see if my calculator can back me up, just in case you're feeling uncertain or uncomfortable with this times 10 to this stuff. You're going to see on your calculator, whether you're using a graphing or just a regular scientific, somewhere there should be a 10 to the x option. If you go in and use that, you're probably going to have to hit your second button. I'm going to enter 10 to the third. I see that I get 5,600, exactly as predicted just by moving my decimal space over. So if you're ever confronted with scientific notation and are feeling uncomfortable with it, feel free to just use your calculator, be careful with parentheses, and you should get yourself to the same answer spot.